Hello and welcome to P9. This is our last section of this chapter. All right, this in here is all about inequalities. So it's your greater than and your less than signs with your equals. And let's see how we do. Again, it shouldn't be too long, so it's an easy video to kind of watch. And let's go. All right, when you're looking at interval notation, this might be a little new. Before you would have used open and closed circles, and we're going to use parentheses and brackets. We're going to talk about intersection and union. So where do they overlap? And when are they all inclusive? We're going to solve linear inequalities, no quadratics today. We're going to do inequalities that have no solutions or all solutions. Compound inequalities are your absolute and your absolute value. So two inequalities in one equation and an absolute value inequality. Let's go. Now when you're looking at these things, this is just notation. Open intervals, at one point you probably used open circles here instead of parentheses, and that is not what I want. Because the new notation is the open circles and the parentheses and the brackets. So on here you would have had two numbers, let's just call them A and B. And the old way, you would have said, hey, there's an open circle here and an open circle here, and you would have like scribbled in between or something. The new way is the parentheses. So this means it does not include, it does not include A or B, but it gets close to A and B because we had two less than signs. The equal sign, you still have your two numbers on your number line, but now the equal sign, so X is greater than or equal to A when you read it this direction. So that's a bracket because it includes A, and less than or equal to B, so that's another bracket facing the other direction because it includes B. And you're including all the numbers between A and B. All right, greater than only. So now we have A again. Greater than without an equal sign means it's a parenthesis, and it goes on forever since it goes to infinity. Now B, it's less than because it's a negative infinity over here. So B is here, but it can go up to B because that's an inclusive bracket. So it goes this way and includes all the numbers to the left of B. Here we go. So we have 1 and 5.6. Let's put 1 here, 2, 3, 4, 5, like roughly here, 5.6. So 1 is my parenthesis facing this way, so it's greater than 1, not included, up to 5.6, inclusive, so that's a bracket. That's all you do. Okay, try yours. All right, all you need to do is put a 7 on your number line. A bracket means inclusive, so oops. And then it goes this way forever. Now let's look at the rest of this. All right, we're going to look at union and intersection. Intersection is an AND graph. All right, it's what they both have in common, and the intersection looks like this, and it's AND. It has to be in both of them. Union looks like this, and it's an OR graph. It's one or the other or both. So let's look at these numbers. We have 5 to 9 inclusive. So we have this 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so we go 5 to 9 inclusive. So my first graph is here. Let's change color so you can see the second one. The second graph is not inclusive because it's parentheses. It starts at 6. So it goes here, maybe. And it goes to 15 and not inclusive on 15 also. So it goes to here. So my second graph is this red one. Now, if I'm going to do the intersection, because it said find intersection and union. So intersection, union. Intersection is what they have in common. So where do they overlap? Where are both lines? Well, both lines are between 6 and 9. It does not include the 6. It does go to the 9, and the 9 is inclusive because it's a bracket. So that's your intersection. Your union is everybody. So where does it start? It starts at 5, inclusive, and it goes all the way to 15, but 15 is not inclusive. So that's your union, where everybody is, okay? Stop and try yours. Okay, let's put these numbers on here. -2, 0. All right, our first one goes from -2 inclusive, so that's a bracket, to 1 non-inclusive, so that's a parenthesis, and that's my first graph right here. let's do red again. My second graph starts at 0, and it goes to 6 inclusive, and that's this graph right here, so it's this one. You have to find intersection and union again. Intersection is where they overlap, so where do I have the blue and the red line? That's between 0 and 1, and both of them are not inclusive. So it goes 0 to 1, parentheses, so they're open. Okay, your union, where does it start and where does it end? So it starts at -2, inclusive. It ends at 6, also inclusive. I hope you did well. All right, now we're going to solve a problem and graph it, so you can see what all your answers could possibly be. So we solve like normal. Let's subtract our 2. So now we have -3x is less than 3. Divide by your -3. Remember, when you divide by a negative, you have to flip your inequality. So x is now greater than -1. So on my number line, we have -1. Greater than, not equal to, so I know it's a parenthesis. Greater than means all the numbers to this direction is what includes it. So 0, 5, 700, 1,378 are all solutions to x is greater than -1. All right, let's go here. All right, let's see what happens here. Let's distribute our 3. Oh, actually, I want you to try them first and then come back and look. Okay, good. So now we got 3x plus 12 is greater than 3x plus 1. But when I subtract the 3x, I just have 12 is greater than 1. It canceled on both sides. Well, when is 12 greater than 1? This is always true. So this goes from -infinity to +infinity. It's the entire number line. Now, how do you write the entire number line in set builder notation? There's a couple of ways. I'll show you one. You can just write like this: x such that -infinity is less than x and x is less than infinity. That would be everybody. You could also say x is a member of the rational numbers. Let's try this one now. So now you got 5x plus 20 is greater than 5x plus 31. Subtract your 5x. All right, again, these 5x's go away. But now we have 20 is greater than 31. This is not a true statement. This is never true. So it's false, which means it's the empty set. There is no such thing. All good? Now let's go down here. This is compound. That just means you have 2 inequalities. You have to be careful. This one has an equal, so we know this guy's going to be a bracket on this one. This one here's a greater than, so we know he's a parenthesis. Not sure which direction yet. We just know what they are. So now let's subtract the 3 from both sides of the inequality. So you have -2 is less than or equal to, don't forget him, 2x, which is less than 8. Divide everybody by the 2, all equalities, so you got -1 less than or equal to x, which is less than 4. So let's put our -1 on our number line, 0, 1, 2, 3, 4. All right, so -1, I know x is greater than, if I read it this way, x is greater than or equal to -1. And that's inclusive, so I got to have a bracket on -1, greater than going this way. X is less than 4, not inclusive, parenthesis, going this way. So it's everything between those two things. To write this in set builder, all you do is add the x's such that with your braces. I hope you did well on that. These I think are kind of fun to play with. All right, the thing to remember about absolute value is there's always 2 solutions. If it's less than, it's an and graph, it goes in. If it's greater than, it's an or graph, it goes out. And this should have had a negative right here. It's a typo, so please fix that. So let's do this together, and then you do the other one. First we got to write this right, because this just bothers me. So go 6 minus 3x, the absolute value, is greater than 18. Now, I just write this in 2 ways. The first thing, I write it as if it's positive. Minus 3x is greater than 18. You write it without the absolute value. Or, now I have to write it with a -18. So the 6 minus 3x does not change. But when I make this a -18, I have to flip this inequality here. So instead of greater than, he becomes less than, because you technically multiplied by a negative. So you got to do that. Solve for your x, so let's subtract the 6. So the negative 3x is greater than 12. You're dividing by a negative 3, so make sure you flip your sign. So we know, let's go down here a little bit, x is less than negative 4. Same over here, subtract your 6. So negative 3x is less than a negative 24. Divide by a negative 3 again, so we got to flip our sign. So x is greater than 8. Let's graph these. So I'm just going to write them on here. Negative 4, less than, so he's going this direction. Let's pretend the 8 is there. Greater than, parenthesis again because it's not inclusive, it's there. And that's your graph. So we have x is less than negative 4, or x is greater than 8. For set builder, you just do such that, and that is your set builder notation right there. All right, try yours. Your first step, you should have written it as is because that's your positive value. Next step, you have to do the negative. So 3x plus 18, you're making the 15 negative. So you have to switch your less than sign to a greater than. Okay, subtract your 8. So 3x is less than 7. Divide by 3. So x is less than 7/3. Here, subtract your 8. So 3x is greater than a negative 23, right? Yeah, it's not going to divide pretty either. Divide by 3, so x is greater than a negative 23/3. So I go to, I'm just going to write these on here, negative 23/3, greater than, not inclusive again, so that's going this way. 7/3 is over here somewhere. Less than, not inclusive again, so it's going this way. So now when you write your set builder, we have x such that x is between these two things. So it's negative 23/3 is less than x, or x is greater than, which is less than 7/3. Set builder notation. Did you do a good job? All right, good luck on your homework. And then we have a chapter review and a test, so make sure you're posting online. Have a great day.